Good morning. Welcome to today's BPA Energy Efficiency webinar. So I'm going to go ahead and introduce our presenter today. We have Joanne Wong. Joanne is a market research project lead in BPA Energy Efficiency Planning and in the evaluation department. She manages market research related to motors and drives and residential HVAC. So Joanne, I'm going to go ahead and turn this over to you.
Thanks, Maggie. Can you hear me all right?
Yes.
Okay, sweet. I will go ahead and get us started. Thank you, everyone, for being here today. I can't really see the list of participants, but I know there's many. I'm so grateful and excited to have you all here today to talk about industrial pumps and fans. So today we're going to talk about the industrial sector here in the Northwest, and specifically about standalone pumps and fans serving industrial facilities. I also have my consultants from Cadeo who did a lot of the technical work here on the call. So I've got Nate Baker and I believe Sarah Witter, who will help me sort of field all the questions you have throughout the presentation. So again, like Maggie said, feel free to type your questions along the way in the chat box, and then we will make sure to get those questions answered promptly. Okay, so the industrial sector, as you all know, energy used in the industrial sector is quite different from other end uses that we interact with every day in our homes and our offices. We're talking about a very diverse and energy-intensive sector here, with many different industries and manufacturing processes ranging from French fry factories to lumber mills. Together, these facilities make up a big sector here in the Northwest. It's actually the second largest sector in the region, just behind residential, and it makes up 28% of the region's electricity use. And this sector is also going to be very important in helping the region meet our energy efficiency goals in the next few years. For BPA, for example, about 80 average megawatt of Bonneville's 6-year energy efficiency in the next 6 years is going to come from the industrial sector. So, just setting some context here for everyone. As I present the recent market trends that we're seeing in the industrial pump and fan market, I encourage you to think about what these trends mean in the context of energy efficiency. Where do you think the market is heading towards in the next few years? And where do you see opportunities for the region's energy efficiency industry to make an impact? As I said before, I'll try to wrap up the presentation a few minutes before 11. So there's an opportunity to hear directly from you and have a discussion together. Just a reminder for anyone who just joined and trickled in, we are recording this presentation. And so reminder to keep yourself muted, type any questions you have in the chat box, and we will make sure to answer your questions promptly. Okay, so within the industrial sector, standalone pumps and fans are big energy users. As you can see here, electric motors make up 73% of the sector's total electric energy consumption. And pumps and fans are the largest category within that motor's end use. So just pumps and fans alone consume a quarter of the region's total industrial energy consumption. And because of this, our team decided to build a market model on industrial pumps and fans so we can study how these equipment and their energy consumption is changing over time, over the past few years. And we aren't the only ones thinking about these systems. There has been a lot of action on the energy efficiency front in the pump and fan and motor markets over the past few years. So from a regulatory perspective, the DOE established a test procedure and energy conservation standards for commercial and industrial pumps in 2016. This process also produced the Pump Energy Index, the PEI, which is a metric aiming to more accurately represent equipment efficiency. And since then, the Hydraulic Institute, which represents pump manufacturers, has been using PEI and the federal standard to promote the adoption of more efficient pumps. And then on the fan side, AMCA, the Air Movement and Control Association, they also established a similar metric called the Fan Energy Index, FEI, and that's also to help better capture the equipment efficiency for fans. And all of these metrics are used here in the Northwest too. So they're used by NEA to help promote efficient equipment and also used by the RTF to estimate savings in its pump and fan UEF measures. So I think all this is just to say that the pump and fan markets have really begun in recent years to recognize the value of energy efficiency, which is really, really great news to us because it makes this particular point in time a very exciting time to be working on getting these equipment to be even more efficient. So what I just mentioned on the previous slide, all those efforts, they focus on improving the efficiency of the pump and fan equipment itself, which gives you about 1 to 5% savings. And similarly, motor efficiency improvements gives you about the same level of savings. And those efficiency improvements are really great and very important. In addition to those, when you add an adjustable speed drive to control these equipment, you can further save a significant amount of energy for the equipment. And what I mean by ASDs, or adjustable speed drives, is any form of electronic control that allows a motor to operate at different speeds. And the majority of ASDs are variable frequency drives, VFDs, and variable speed drives, which you may be more used to hearing. So with ASDs, you can much better control the motor speed and better serve the pump or the fan, and thus significantly reducing their energy consumption. And in addition to saving energy, ASDs also have other non-energy benefits that make them attractive to industrial facilities. So for example, they help with process control, and they also serve as that digital access point to more analog machines, and that's really critical in sort of the adoption of the industrial Internet of Things. So our team built a market model to quantitatively measure ASD adoption here in the Northwest and also estimate how much savings ASDs have brought to the region's industrial sector over the past 6 years. We collected the most accurate and up-to-date data that exists out there to use as inputs to our model. We first estimate the region's total motor horsepower industrial pump and fan stock and how that's changed over time. We then used region-specific market data to inform how that ASD saturation has changed over time. Finally, we have a very granular methodology to estimate energy consumption of individual pieces of pumps and fans, and we combine all of those inputs, and the model that we built is able to give us quantitative estimates of the region's annual industrial pump and fan energy consumption from 2016 to 2021. You see expert review here on the slide. I just added it this morning because throughout this entire process of model development, we worked with a panel of industry experts and stakeholders to help review and vet our work. And I just want to give special thanks to all of these panelists, and I know that some of them are on the call today. The panelists ranged from representatives from the council and NEA, as well as industry organizations like the Hydraulic Institute and NEMA, the Motor Association. And because of these panelists' direct industry experience, they were not only able to provide feedback that help make our model better, they also provided just interesting insights and observations about the market that helped corroborate our model results, which I'll try to sprinkle throughout the presentation as I show you some of the interesting findings that we're seeing. So what do we learn about the market? So first, I'm going to talk about high-level insights on industrial pump and fan stock and energy consumption. And then we're going to move on and focus on ASDs, adjustable speed drives, the energy savings that ASDs gave us, and then more specifics about where ASDs are being installed. Okay, just one last reminder for maybe the last few that have trickled in. We are recording this presentation, and so we're asking you to keep yourself muted and type any questions you have in the chat, and we'll get them answered. And I don't see any questions typed yet, so that's a good sign. Okay. All right, so first of all, the stock of industrial pumps and fans looks pretty much like you would expect. So the blue line on this chart here shows a slow growth in total industrial pump and fan motor horsepower stock over the past 6 years. And this is pretty in line with the growth of the region's industrial growth output in that same period. We do see a slight decline in the past couple of years due to the global pandemic and the supply chain issues that we all experienced over the past 2 years meant that it was difficult to get goods from production to the consumer, and so that actually meant that production in some cases had to slow down as well. And we saw industries like refineries and transportation showed a large decrease in production. Whereas, interestingly, a couple of industries like electronics and computers actually grew in those past 2 years. So one interesting finding we had specific to pumps is that the average industrial pump size has increased from about 30 horsepower in 2015 to almost 37 motor horsepower in 2021. This is a pretty significant change if you think about this being the average motor size. Whereas on the fan side, the average industrial fan size has pretty much remained the same at around 17 to 18 motor horsepower. And the reason this average pump size has increased is because industries with larger pump motors like chemical and refinery are growing faster in a region relative to industries that have relatively smaller pump motors. And while that stock of motor horsepower grew pretty consistently over the past 6 years, as you can see in that same dotted line that I showed you before, the energy that those motor horsepower consumed actually remained pretty flat. So that is the blue area shown here, kind of overlapping that motor stock. So giving you a couple more metrics here, while the motor horsepower stock increased by about 4% over the past 6 years, energy consumption actually decreased by about 2%. In other words, there's more motors in the stock consuming energy, but that energy consumption has not increased. So if you combine those two kind of slightly juxtaposing trends, that meant that the average per unit, so per horsepower energy consumption actually decreased over the past 6 years. And that occurred for both industrial pumps and fans. And you can see that decrease across these blue bars here, and that's pumps and fans combined. And then the red and green data labels are showing that decrease more specifically for pumps versus fans. So improvements in pump and fan and motor efficiency, they all contributed to this decrease in per unit energy consumption. But the major driver in this decrease is the accelerated adoption of the ASDs that we saw here in the region. So transitioning into ASDs. What's going on with ASDs? This chart is showing the saturation of ASDs, which is the percent of pump and fan motor horsepower stock equipped with ASDs. And it's showing that that's increasing. And the diamonds that I have here on the chart here are actually representing ASD saturation across the whole country. And you see that national ASD saturation for both pumps and fans increased by about 10 percentage points over the past 6 years. Compared to the nation, ASD saturation here in the Northwest is not only higher, it's also growing faster. So now I'm showing the ASD saturation specific to the Northwest region in the circles here. And as you can see from the trajectory of the green circles representing fan ASD saturation here in the Northwest, you see that it's just slightly higher than the national average, and it's growing at a pretty similar pace as well. But for pumps, so the red circles, we see a much bigger difference in the Northwest versus the country. Not only do we see that it started higher, so it started, the ASD saturation started higher at the beginning of this time frame, we also see that it's growing faster, and it landed at just shy of 60% in 2021. So these differences in ASD saturation are pretty interesting. They align with what we have heard from industry experts in the field. And what we heard consistently is that ASD saturation in the Northwest is bigger than the rest of the country. And experts also noted that utility programs promoting ASDs here in the region are a key reason for the healthy adoption that we see here. So ASD adoption has had a direct impact on energy consumption, and it's one of the driving reasons why the region's industrial pump and fan energy consumption has not increased in the past 6 years. So this chart is showing energy consumption again, but kind of slightly blown up so we can see the impact that ASDs have more clearly. And we wanted to isolate that impact. So we modeled the energy consumption, what it would have looked like if that increase in ASD adoption had not occurred. And the way we did that was we built a baseline case where we assumed that ASD saturation from 2016 to 2021 remains fixed at what it was in 2015. And so as you can see, the actual energy consumption is represented by that area in the teal blue, and then the increase or the difference between the actual energy consumption and that baseline case represents savings that we can directly attribute to ASDs. And that increase is over the past 6 years amounted to about 27.6 average megawatts of savings. If we put that number in a more digestible form, that's the equivalent of the annual energy consumption of about 20,000 Northwest homes. So ASDs have brought us a lot of savings in the region in the past 6 years. Now, let's shift gears a bit from savings and dive deeper into where those ASDs have been getting installed in the region. A reminder, again, that we are recording this presentation. I do not see any questions typed in the chat so far. I encourage you to ask any questions you have along the way, and we will get them answered. And thanks so much, everyone, for keeping yourself muted. Okay, so what kinds of equipment are getting ASDs? We saw two big installation trends. First, we saw that ASDs are concentrated in variable load systems, or systems where the pump or the fan is trying to meet a more fluctuating load. And second, we saw ASDs primarily installed on systems with larger motors. So the market experts we spoke with said that these trends make sense if you think about the amount of energy that you could save with both variable load and larger systems. So looking at load variability, the more fluctuation there is in the system's operating point, the more that drives can do to help efficiently meet that load. And of course, you still save energy with less variable load or constant load systems to either match that less fluctuating load or even right-size the system. But the energy that you save is just not as much as for variable load systems. And then on the right side, the reason why ASDs are more often installed on larger motors, again, is tied to savings. So on a per equipment basis, the larger the motor, the more absolute savings you would get per ASD. And while that cost of ASD might be increasing as the motor size increase, oftentimes it's not a proportional increase. So you're most likely going to get a larger or actually shorter payback period when you install an ASD in larger equipment. Interestingly, while the majority of ASDs are installed on variable load systems, like I just talked about, we're starting to see more and more ASDs being installed on constant load pumps. And if you remember earlier, we showed that the pump ASD saturation in the Northwest has increased quite a bit over the past few years, reaching almost 60% of the pump motor horsepower stock. Reaching that level of saturation in the market, it means that not only are tons of variable load pumps getting ASDs, so are an increasing number of constant load pumps. And from our interviews with market actors, we identified a few observations that might support this trend. So first, the cost of ASDs has come down in the past decade, meaning that systems with smaller energy savings, such as more constant load applications, are able to more easily justify that cost of getting an ASD. And second, facilities are more and more familiar and comfortable with this technology, and they may be more comfortable putting ASDs on a broader number of applications. And thirdly, it's the non-energy benefits that I talked about earlier, where facilities are recognizing that ASDs can bring you more benefits with process control, and that has enabled them to put more drives on more different types of systems. Okay, so I do see a question in the chat. Joanne, could you clarify whether the 2026 average megawatts value in slide 13 represents the impact of regional E programs, or does this figure represent the wider national market adoption trend? So yeah, so let me back up. Oh, I don't know how to back up on the slide, but the 27.6 average megawatts is specific to the Northwest region, and it's the total cumulative savings the region has achieved over the past 6 years, 2016 to 2021, from the increased adoption of ASDs, and it's the total in the market. So it includes regional energy efficiency program efforts, incentivizing ASDs, but also the market adopting ASDs on its own. I hope that answered your question. If not, please follow up. Okay, so going back to where these ASDs are getting installed. We also looked into different industrial facility types and what kinds of facility types are getting ASDs. So our model segments the industrial sector into 11 different facility types. And we found that ASDs are not equally distributed across these facility types. We saw that for pumps, so this is showing just for pumps, the 5 facility types highlighted here, so chemical, fabricated metal, food, computer and electronics, and miscellaneous manufacturing. These 5 have the highest ASD saturation as of 2021 relative to the other facility types in the region. And these are also the same facility types where we saw the fastest growth in ASDs over that 6-year time period. For fans, we see most of those same facility types as having the highest and fastest growing ASD saturation as well. And it looks like for fans, transportation did make it in here in the top 5. And there could be many reasons why these particular industries are doing better than the rest. One reason could be whether that industry has an emphasis on process control. For example, industries like chemical have very precise requirements around that process, and ASDs can help meet that, those requirements. Another reason could be whether the industry has a more technical focus, like computer and electronics. They may be more aware of the technology and thus adopting more on their own. And of course, these differences in ASD saturation also have a lot to do with where regional utility programs have invested in their program incentives. And to explore that a little bit further, I'm going to use the next few slides to talk specifically about the region's ASD program activity and how that's kind of, like Steve, I think what you're asking is how that's sort of been a part of the overall market adoption. So the region's energy efficiency programs have promoted ASDs for a long time. ASDs were recognized as a measure in both the 6 and the 7 power plans, and of course they're also part of the 2021 power plan. We did a deep dive into regional program data. We also conducted several interviews with different utilities, and we learned that ASDs specifically on industrial pumps and fans are almost exclusively incented through custom programs. And as you all know, these custom programs, they go deep, as we're trying to convey here with the Cave Explorer shown on this slide. They go deep to understand each industrial facility's systems and how they operate, and they do that so that they can maximize the energy savings for industrial facilities. Since custom projects collect a lot of rich data, we were able to get our hands on BPA's custom project data, and we looked at 150 BPA industrial pump and fan projects that included ASDs as one of the measures. And we saw that savings from adding ASDs to variable load systems have consistently delivered about 2,000 kilowatt hours per motor horsepower. And that was like a pretty exciting finding for us. It means that while there'll always be outliers, for example, there'll always be some pumps that only operate half an hour a year, or fans that are running nonstop the entire year. If you put aside those outliers, we can pretty much expect to save around 2,000 kilowatt hours per horsepower from adding ASDs to variable load industrial pumps and fans. And it was really, really exciting for us to see such a strong central tendency around those savings values. Another insight we got from program data is we saw that program activity concentrate in even fewer facility types than the market overall. So this is showing just for fans, more than 90% of the total fan motor horsepower incented by utilities to install ASDs are in either chemical, food, miscellaneous, and wood. And not surprisingly, these facility types are also one of the ones where we saw the highest ASD saturation in the market overall. And what does that mean? That means that program investments have great influence on the market adoption of ASDs. For pumps, we see chemical, food, and miscellaneous manufacturing show up again as having the most program-incented ASDs. We also see paper added in here. And together, these 4 facility types received almost all of the program incentives for ASDs on pumps. And programs don't just influence the market through direct financial incentives. They also provide staff engagement and education around the ASDs, which helps create an environment where the industry itself recognizes the benefit of ASDs and is able to start adopting ASDs on its own. We also saw that programs are driving some of those trends we saw in the overall market. So namely that ASDs are installed in more larger and more variable load systems. And that reason is simple. It's what I was saying earlier with the custom programs and how they target the highest energy savings opportunities. And I wanted to illustrate this point with more data. So we were on this donut chart here, we saw that programs incented about 1/5 of the industrial pump and fan motor horsepower that installed ASDs in the past 6 years, right? The programs touched 1/5 of the market. But those incented motor horsepower actually produce a much larger energy savings, so much larger portion of the energy savings. So in this next donut chart here, you see that program incented motor horsepower actually produced 1/3 of the overall motor horsepower that adopted ASDs in the past 6 years. So even though programs only touched or incented 1/5 of the market, their overall energy savings impact is close to 1/3, which is really exciting. Okay, so I've just shared with you all of the key insights we have on the industrial pump and fan and motor and drive markets over the past 6 years. Now I want to spend the last section of the presentation to talk about where we go from here and what's remaining in the market. So there's still a lot of remaining potential for ASDs. Our model shows that 57% of the region's industrial fan motor horsepower stocks are not equipped with ASDs. And that's almost 700,000 motor horsepower as of 2021. And on the right, for pumps, you see that that portion is slightly smaller, but it's still a significant portion. About 500,000 motor horsepower, pump motor horsepower in the region are still not equipped with ASDs. So if we zoom in on the portion of that motor stock without ASDs, we see that split between variable load and constant load. And we see, of course, variable load shows up as a pretty good chunk of that remaining potential. But the exciting or interesting to me part of these donut charts is that constant load applications are actually the majority of the remaining potential. For example, for fans, you see on the left here that 63% of the fan motor horsepower that doesn't have an ASD is in constant load. And then for pumps, that's 71%. So big caveat here, these graphs are showing the remaining potential in terms of motor horsepower, right? And the portion of that motor horsepower without ASDs. From an energy savings or average megawatt perspective, it's a different story. So if you imagine a hypothetical world where all of the region's remaining fan and pump motor horsepower stocks got an ASD, that could give us more than 100 average megawatts of savings potential. And so there's plenty of savings potential left in this market. And if you, again, look at the savings or average megawatt perspective for the potential, constant load systems hold only about 1/3 of that remaining potential. And that's, again, because ASDs on constant load systems are, they save relatively less energy than on variable load systems. But if you look at these donut charts, constant load systems hold a significant chunk of the remaining potential. And so I think looking ahead, something that will be interesting for the region to think about is how do we put ASDs on both variable load and those harder to reach, slightly less savings, smaller savings systems. The last piece of data I will leave you with is which facility types have the most remaining potential for ASDs. The majority of the Northwest industrial pump and fan motor stack without ASDs falls into 5 facility types, and they're listed here. So for fans and pumps, across the board, it's wood, primary metal, paper, warehousing, and refinery. And there's a couple other smaller ones as well. And of those 5, utility programs are already really active in wood and paper. And we believe that as long as the region continues to offer custom programs, these more sort of motor-intensive industries like wood and paper will continue to be encouraged to adopt ASDs. On the other hand, facility types like primary metal, warehousing, and refinery are the ones where an increase in program engagement could potentially be very impactful. Now, I'm sure there's many existing challenges in implementing programs in these particular sectors, but as far as the data can show us here, we see that those 3, so primary metal, warehousing, and refinery, those 3 are the lagging facility types where more influence from programs might really help boost their ASD awareness and adoption. Okay, so zooming out for a little bit, I want to talk a little bit, hold on, let me go back to the previous slide. I want to talk about not only what's left to do, but also how it fits into the bigger picture with the industrial sector being an important part of our energy efficiency goals in the next 6 years. I think we are on a really good path to get there. So I want to highlight a couple of efforts that are currently going on in the region besides the region's existing custom programs that are helping boost ASD adoption. So NEIA's XMP initiative, it focuses on not just the adoption of efficient pumps, but also pumps with integrated ASDs. And I know NEIA is, I believe, currently in the process of developing a program around efficient fans as well. And they're also looking preliminarily at opportunities to promote retrofit drives. And in addition to NEIA's efforts, as most of you probably know, the RTF does have planning measures for ASDs in small pumps, fans, and VFDs. And all of the information that our market research team has gathered through this market modeling work, all of this information can be used by the RTF to potentially expand its measure sets and enable utilities to implement more ASDs. So there's a lot going on in the region already, ongoing, that is helping us put more drives on these equipment. And then zooming out from that region and utility program perspective, I also want to share several other exciting activities more globally and nationally that's going to help just put more recognition on ASDs. So NEMA, the motor industry organization, has worked with NEIA actually and published the Power Index, or PI. And this metric is, it accounts for both component efficiency and input power. And so it accounts for the impact of ASDs and component efficiency in the same metric. And that's really going to help keep highlighting and promoting the impact that an ASD can have on different equipment. And so I encourage you, if you don't know about this already, to read about it more. It's the Power Index, and talk to Nia about this more. And then more nationally, the U.S. Congress recently passed the infrastructure bill, which included $10 million specifically focused on increasing ASD adoption in commercial and industrial facilities. So that's really cool. And then more on the global scale, European regulatory organizations are including ASD control as part of their energy conservation standards. And they've been actually accounting for part load efficiency in their motor regulations for a long time. So again, just to drive this home, the message is we are not alone in all of the exciting initiatives going on in promoting ASDs. And I know our region has a proven record in collaboration with each other, and I'm really confident that we'll see more innovation and advancements to get more ASDs in the field. So I want to touch briefly on future research before we wrap up here. So this is my last content slide, and we're at 10:45, which is great. So what we learned from modeling this industrial pump and fan market is that we need more information. We need information both on pumps and fans and what's going on in the market. We also need more information on the industrial sector as a whole. And so I'm highlighting 3 different areas where we think it's important to do more research. One is load profile. So we learned that pump and fan load profiles are the biggest driver of uncertainty in the model, not operating hours. Load profiles are very important, and it's especially important because of that distinction between more variable load and less variable load systems. And so getting more data on pump and fan load profiles would really help refine our energy consumption estimates and help improve our understanding of ASD savings. And this is also something the RTF VFD research strategy also flagged as an important area of research that the region needs to continue to invest in. And second, ASD saturation. Of course, research into ASD saturation is going to really help improve our understanding of ASD adoption, and continued research is going to help make sure that we're keeping track with the market and up to date on how ASD adoption is changing over time. And as I noted kind of throughout this presentation, what we're seeing in the market is that ASDs are being installed, and where they're being installed is changing over time. And it means that the impact that ASD have can differ by application. And so research into ASD saturation at a more granular level is going to help us more accurately characterize that impact. And then lastly, I put motor stock assessment, and this kind of touches on the need to have a more updated picture on the industrial sector here in the Northwest overall, but perhaps even more focused on the motor end use. It's really going to help us not only with our understanding of the pump and fan stock, but also other motor applications with energy savings potential. So if you remember all the way in the beginning of this presentation, I showed you that the motors end use in the industrial sector is 3/4 of the industrial sector's energy consumption. And within that motors end use, pumps and fans are only about 1/3 of that of motor-driven energy consumption. And so there's other motor-driven end uses like compressors and material processing that also have the potential to save with ASDs, and that's not something that our existing research has covered, but it's something we should look into. And all of that cannot be done without more updated information on the industrial sector as a whole here in the Northwest and a more specific look at the motor stock. So these are the three that we're looking to focus on in the next few years. And I think these are things that I believe, together with NEIA and different utilities in the region, we can make a large impact. I want to just thank you so much for attending this presentation. We did just publish our model report. If you are interested for more information on this website here, and also Bonnie helped type in the chat, we have not only the report, also we'll be posting this particular presentation there as well, and we have more detailed model results in the workbook. Everything is up there. If you have any more questions, here's my email address on the slide. Feel free to email me anytime. And yes, thank you everyone for coming. And I think with that, we can end this call.